question or on question 2B of test 3 from 2019. And in this question, you're told that chromate can displace silver from solution according to this equation here that has already been balanced for you. So the first part, you're asked for the E0 cell at 298, and you're given the reduction potentials for chromium 3+ to chromium and also silver plus to silver. But in order to find E0 cell, you need to know which one's going to be oxidized, reduced, or what's your anode or your cathode. If you look up in the reaction up here, we see our chromium is going from 0 to +3. So our chromium is being oxidized. And then our silver is being reduced. So if you remember, oxidation happens at the anode, reduction happens at the cathode. So to find E0 cell, remember it is E0 of the cathode minus E0 of our anode. So by putting these two in there, we should get a value of plus 1.53 volts. So that was part 1. The second part of this question wants to know what delta G is. Our delta G0 at 298. If you remember our equation for delta G0 involving E0, because we just calculated that, minus NF E0 of the cell, or Z. Kind of interchangeable, especially in this case here when we're just looking at a balanced equation and not necessarily amounts of something. You can use Z in this case here. So knowing from here, we have E0 cell, you know F, we need to find N. And N you would get from balancing the equation, because that's the number of electrons that need to be transferred from one species to the other. So if we were looking at each of these half reactions, break it down, we have chromium going to chromium 3+, to balance that, 3 electrons. And the other one is silver plus going to silver. So with the charge on there, 1 electron, you can see how now you have to multiply this whole thing by 3 in order to cancel out your electrons. So in this case here, N is 3 electrons. Okay? So you know N, you know F, you know E0 cell. So delta G0 in this case here is minus 4.43 times 10 to the 5, and that's in joules. Now the third part of this, you're the crying kid in the background, if you can. Okay, part 3 wants to know, is this spontaneous or not? So the values we got, E0, we had a positive value. Delta G0, we had a negative value. That tells us, one or the other, that this was a spontaneous reaction. Part 4, we want to know the maximum amount of work that can be derived per mole of chromium reacted by silver plus and at standard state. So that would be delta G0. From our equation, it was already per mole of chromium. So remember, our max work is equal to our delta G. And in this case here, it is our delta G0 because we're talking at standard state. So that means our max work is minus 4.43 times 10 to the 5 joules. Keep in mind, that's the amount of work done by the system on the surroundings. And finally, part 5. This is the cell notation. How are you to write this out if you wanted to in short form? Remember, you always have anode first going to cathode. So at our anode, we talked about that's the oxidation reaction. Our oxidation reaction was the chromium going to chromium 3+. And we always separate the different phases with vertical lines. So chromium going to chromium 3+. Physical divide, also a salt bridge in there. And then you have your reduction equation or your reduction reaction. So what's going on at your cathode? And your cathode has the silver plus turning into metallic silver. You don't need to have the 3s in here. You get that from balancing equations, and that's not necessary. You could also put in the concentrations. So in this case here, because everything is just in standard state, Aqueous, 1 molar. So not really necessary in this case here. If this was a different concentration cell, you'd have to specify that concentration. And that's the end of question 2B.